near class 10 math second chapter 5th coordinate geometry practice set 5.1 compiled by Abhishwar Bhansali BSc MSc B.Ed for the Pacific coaching classes near for the year 2022 and 23. Question first, find the distance between each of the following pairs of the points. The coordinate of the A is 2 and 3 and the coordinate of the B is 4 and 1. The coordinate of the P -5 and 7. The coordinate of the Q is -1 3. R 0 -3. S 0 and 5 upon 2. L 5 and -8. M -3 and -7 and -3. T -3 plus 6. R 9 and -10. W -7 upon 2, 4 and X 11 upon 4. First, the coordinate of the A is 2 and 3 and the coordinate of the B is 4 and 1. Solution. Let assume that the coordinate of the A is x1 y1 and the coordinate of the B is x2 y2. Then x1 is equal to 2, y1 is equal to 3, b1 is equal to y1 is equal to x2 is equal to 4 and y2 is equal to 1. By distance formula we get distance between the point A and B is equal to under root of x2 minus x1 bracket square plus y2 minus y1 bracket square. Distance of AB, by putting the value of the x2 and x1, y2 and y1 we get under root of 2 square plus minus 2 square. Therefore under root of 4 plus 4. Therefore distance of AB is equal to under root of 8. Distance of AB is equal to 2 under root of 2 units. The distance between the point A and B is 2 under root of 2 units. P and Q. The coordinate of the P is -5 and 7 and the coordinate of the Q is -1 and 3. Let assume that the coordinate of the P is x1 y1 and the coordinate of the Q is x2 y2. Then we get the value x1 is equal to -5, y1 is equal to 7, x2 is equal to -1 and y2 is equal to +3. Then by distance formula we get the solution as distance between the P and Q is equal to under root of -1 minus -5 square plus 3 minus 7 square. -1 plus 5 square plus 3 minus 7 square. Therefore distance of PQ is equal to under root of 4 square plus -4 square. Therefore distance of PQ is equal to under root of 16 plus 16. Therefore distance of PQ is equal to under root of 32. Therefore distance of PQ is equal to 4 under root of 2 units. The distance between the point P and Q is 4 under root of 2 units. Third one is the R and S. x1 y1 x2 y2. x1 is equal to 0, y1 is equal to -3, x2 is equal to 0 and y2 is equal to 5 upon 2. By distance formula we get the 0 minus 0 bracket square plus bracket 5 upon 2 minus bracket -3 bracket complete whole bracket complete square. Therefore we get the distance of R and S is equal to under root of 5 upon 2 plus 3 bracket square. Distance of R and S is equal to under root of 5 plus 6 upon 2 bracket square. Distance of R and S is equal to under root of 11 upon 2 square. Therefore distance between the R and S is equal to 11 upon 2 units. The distance between R and S is equal to 11 upon 2 unit. The distance between the point R and S is equal to 11 upon 2 unit. Fourth one, L and M. The coordinate of the L is x1 y1 x2 y2. By putting the value x1 is equal to 5, y1 is equal to -8, x2 is equal to -7 and y2 is equal to -3 in the distance formula we get -7 minus 5 bracket square plus -3 minus -8 square. Distance of LM is equal to under root of -7 minus 5 bracket square plus -3 plus 8 bracket square. Distance of LM is equal to under root of minus 12 square plus 5 square. Distance between the L and M is equal to under root of 144 plus 25. Distance between the point L and M is equal to under root of 169. Distance between the L and M is equal to 13 unit. The distance between the point L and M is 13 unit. The fifth one is the T and R. The coordinate of the T is minus 3 and 6 and the coordinate of the R is 9 and minus 10. So it is the x1, it is y1, it is x2, it is y2. By applying the distance formula, we get distance between the T and R is equal to under root of x2 minus x1 bracket square plus y2 minus y1 bracket square. Distance between the T and R is equal to under root of 9 minus minus 3 square plus minus 10 minus 6 whole bracket square is equal to distance between T and R is equal to under root of 9 plus 3 square plus minus 16 square. Distance between T and R is equal to under root of 144 plus 256. Distance between the T and R is equal to under root of 400. Therefore, distance between T and R is equal to 20. Distance between T and R is equal to 20 unit. The distance between the point T and R is equal to 20 units. Sixth one, W and X. The coordinate of the W is minus 7 upon 2 and 4 and the coordinate of the X is 11 and 4. Let assume that the coordinate of the W is x1 y1 and the coordinate of the X is x2 y2. By putting this value in the distance formula, we get under root of 11 minus minus 7 upon 2 bracket complete whole bracket square plus 4 minus 4 bracket square. Distance between W and X is equal to under root of 11 plus 7 upon 2 bracket square plus 0. Distance between W and X is equal to under root of 22 plus 7 upon 2 bracket square. Distance between W and X is equal to under root of 29 upon 2 square. Therefore, distance between W and X is equal to 29 upon 2 units. The distance between the point W and X is 29 upon 2 units. Question second. Determine whether the points are collinear. The coordinate of the A, B and C are the given one. The coordinate of the L, M and N are given one. The coordinate of the R, D and S are the given one. The coordinate of the P, Q and R the given. Solution by distance formula. Distance of AB is equal to under root of x2 minus x1 bracket square plus y2 minus y1 bracket square. Distance between the AB is equal to under root of 2 minus 1 bracket square plus minus 5 minus minus 3 whole bracket square. Distance of AB is equal to under root of 2 minus 1 square plus minus 5 plus 3 bracket square. Therefore, distance of AB is equal to under root of 1 square plus minus 2 square. Therefore, distance of AB is equal to under root of 1 plus 4. Therefore, distance of AB is equal to under root of 5. Distance of BC is equal to B and C. x2 minus x1 bracket square plus y2 minus y1 bracket square. Minus 4 under root of minus 4 minus 2 bracket square plus bracket 7 minus bracket minus 5 whole bracket complete whole bracket square. Distance of BC is equal to under root of minus 4 minus 2 square plus 7 plus 5 square. Distance BC is equal to under root of minus 6 square plus 12 square. Distance BC is equal to under root of 36 plus 144. Distance BC is equal to under root of 180, and finally we got the distance between the BC is 6 under root of 5. Then distance between the AC we got under root of minus 4 minus 1 bracket square plus 7 minus minus 3 bracket square is equal to 4 minus 1 square plus 7 plus 3 square is equal to minus under root of minus 5 square plus 10 square. Therefore, distance of AC is equal to under root of 25 plus 100 is equal to distance of AC is equal to under root of 125, means distance of AB is equal to 5. On adding 1 and 2, 1 and 3, we get distance of AB plus distance of AC is equal to under root of 5 plus 5 under root of 5, means 6 under root of 5. Distance of AB plus distance of AC is equal to distance of BC from equation 2. Therefore, the point A, B and C are the collinear. The coordinate of the L, M and N are given. Solution: by distance formula, calculate the distance between the L and M, assuming that x1, y1, x2, y2. By putting the value, we get distance of LM is equal to under root of 45 is equal to 3 under root of 5. Distance of MN is equal to under root of x2 minus x1 square plus y2 minus y1 square is equal to 5 minus 1, 5 minus 1 plus 4 minus 3 bracket square. Therefore, we got the under root of 4 square plus 4 plus 3 means 7 square. Distance of MN is equal to under root of 4 square plus 7 square is equal to distance of MN is equal to under root of 16 plus 49. Therefore, distance of MN is equal to under root of 65. Distance of MN is equal to under root of 65. Distance of LN is equal to L and N, assuming that the coordinate of the L is x1, y1 and the coordinate of the N is y2 and y1. x2 and y2, x1 and y1. The coordinate of the L is x1, y1 and the coordinate of the N is x2, y2. By putting the value, we get the distance between the LN is under root of 49 plus 1. Distance of LN is equal to under root of 50. Distance of LN is equal to 5 under root of 2. On adding 1 and 3, we get distance of LM plus distance of LN is equal to 3 under root of 5 plus 5 under root of 2 is not equal to under root of 65. So, distance between LM plus distance between the LN is not equal to distance between the M and N from equation 2. So, point L, M and N are not collinear. R, D and S. By the same method, we calculate the distance between the R and D, assuming that the coordinate of the R is x1, y1 and the coordinate of the D is x2, y2. So, by putting the value in the distance formula, we get the distance between the R and D is equal to 2 square plus minus 2 square is equal to distance between R and D is equal to under root of 4 plus 4. Distance between R and D is equal to under root of 8. So, distance between the R and D is equal to under root of 8. This is called the first equation. By assuming that distance between the D and S, we assume that the coordinate of the D is x1, y1 and the coordinate of the S is x2, y2. By putting that value into the distance formula, we get 3 minus 2 bracket square plus minus 1 bracket square. Therefore, we got the distance between the DS is equal to under root of 1 square plus minus 2 square. Distance between the DS is equal to under root of 1 plus 4 square. Distance between the DS is equal to under root of 5. So, distance between the DS is equal to under root of 5. And the third one, the distance between the R and S, we calculate it by assuming that the coordinate of the R is x1, y1 and the coordinate of the S is x2, y2. By putting the value of that into the distance formula, we get under root of 3 minus 0 square plus minus 1 minus 3 bracket square. By solving it, we get under root of 3 square plus minus 4 square means under root of 9 plus 16 means under root of 25, and distance between the r and s is equal to 5. This is called equation third. On adding first and second, we get distance between the r and d and distance between the d and s is equal to under root of 8 plus under root of 5 is not equal to 5. So distance between the r and d plus distance between the d and s is not equal to distance between the r and s. So point r, d and s are not collinear. Fourth, p, q and r. By distance formula, calculate the distance between the PQ by assuming that the coordinate of the P is x1, y1 and the coordinate of the Q is x2, y2. Put that value into the distance formula. We got under root of 1 minus 2 square plus 2 minus 3 bracket square. Distance between the PQ is equal to under root of 1 plus 2 square plus 2 minus 3 square. Distance between the PQ is equal to under root of 3 square plus minus 1 square. Distance between the PQ is equal to under root of 9 plus 1. So distance between the PQ is equal to under root of 10. Distance between the Q and R. Assume that the coordinate of the Q is x1, y1 and the coordinate of the R is x2, y2. Put that value into the formula and we got under root of 4 minus 1 square plus 1 minus 2 square. Therefore distance between the QR is equal to under root of 3 square plus minus 1 square. Therefore distance between the QR is equal to under root of 9 plus 1. Therefore distance between the QR is equal to under root of 10. Distance between the QR is equal to under root of 10. Distance between the P and R. Calculate that distance by assuming that the coordinate of the P is x1, y1 and the coordinate of the r is x2, y2. We may calculate that under root of 4 minus 2 bracket square plus 1 minus 3 whole bracket square. Distance between the PR is equal to 4 plus 2 square plus 1 minus 3 square. Therefore distance between the PR is equal to under root of 6 square plus minus 2 square. Distance between the PR is equal to under root of 36 plus 4. Distance between the PR is equal to under root of 40 is equal to 2 under root of 10. This is called the equation third. We got the distance between the PQ is under root of 10. Distance between the QR is equal to under root of 10 and distance between the PR is equal to twice of under root of 10. On adding 1 and 2, we got distance between the PQ and distance between the QR is equal to under root of 10 plus under root of 10 is equal to twice of under root of 10. Distance between the PQ plus distance between the QR is equal to distance between the PR. So the point P, Q and R are the collinear one. Question third. Find the point on the x-axis which is equidistant from the A minus 3 and 4 and B 1 and minus 4. Solution. Let point C be on the x-axis which is equidistant from the point A and B. Point C lies on the x-axis. Its y coordinate is 0. Let C is equal to x and 0. The C is equidistant from the point A and B. Therefore AC is equal to BC. By distance formula we get under root of x minus 3 bracket complete square plus 0 minus 4 square is equal to x minus 1 bracket square plus 0 minus 4 square. Squaring both sides we get x minus 3 bracket square plus 0 minus 4 square is equal to x minus 1 square plus 0 minus 4 square. X plus 3 square plus minus 4 square is equal to x minus 1 square plus 4 square. x square plus 6x plus 9 plus 16 is equal to x square minus twice x plus 1 plus 16. Therefore 8x is equal to minus 8. Therefore x is equal to minus 8 upon 8. Therefore x is equal to minus 1. The point on the x-axis which is equidistant from the point A and B is minus 1 and 0. Question 4th. Verify that the point P having coordinate minus 2 plus 2, the point Q having coordinate 2 and 2, and the point R having coordinate 2 and 7 are vertices of the right angle triangle. Solution. Distance between the 2 points is equal to under root of x2 minus x1 bracket square plus y2 minus y1 bracket square. By distance formula we get distance between the PQ is equal to under root of x2 minus x1 square plus y2 minus y1 square. Distance between the PQ is equal to under root of 2 minus minus 2 square plus 2 minus 2 bracket square. Distance between the PQ is equal to 2 plus 2 square plus 0 square. Therefore PQ is equal to under root of 4 square. Therefore distance between the PQ is equal to 4. By distance formula, distance between the Q and R, by assuming that the coordinates of the Q is 2 and 2 and R is 2 and 7. Assume that this is the x1, this is y1, this is x2 and this is y2. We get under root of 2 minus 2 square plus 7 minus 2 square. Therefore we get under root of 0 square plus 5 square is equal to under root of 5 square is equal to 5. By distance formula we calculate the distance between the P and R, assuming that their coordinates are x1, y1, x2, y2. So we get the value under root of 2 minus minus 2 whole bracket square plus 7 minus 2 square. Distance between the PR is equal to under root of 4 square plus 5 square. Therefore distance between the PR is equal to under root of 16 plus 25 is equal to under root of 41. Distance between the PR square is equal to 41. So consider PQ square plus QR square is equal to 4 square plus 5 square is equal to 16 plus 25 is equal to 41. So PR square is equal to PQ square plus QR square. Therefore in a triangle PQR is a right angle triangle according to converse of Pythagoras theorem. According to Pythagoras theorem, triangle PQR is a right angle triangle. So point P, Q and R are the vertices of the right angle triangle. Question 5th. Show that the point P, Q, R and S are the vertices of the parallelogram. Distance between the 2 points is equal to under root of x2 minus x1 bracket square plus y2 minus y1 bracket square. By distance formula we get distance between the PQ is equal to under root of 7 minus 2 square plus 3 minus minus 2 square is equal to under root of 5 square plus 5 square. Therefore is equal to under root of 25 plus 25 is equal to under root of 50. By distance formula we get the distance between the Q and R is equal to under root of 11 minus 7 square plus minus 1 minus 3 square. Distance between the QR is equal to under root of 4 square plus minus 4 square is equal to under root of 16 plus 16 is equal to under root of 32. By distance formula, distance between the R and S given is given by the distance formula. Distance between the R and S is equal to under root of 6 minus 11 square plus minus 6 minus minus 1 square. Distance between the R and S is equal to under root of 5 square plus minus 6 plus 1 square is equal to under root of 25 plus 25 is equal to under root of 50. And the distance between the P and S is equal to 6 minus 2 square plus minus 6 minus minus 2 square is equal to under root of 6 minus 2 square plus minus 6 plus 2 square is equal to under root of 4 square plus minus 4 square is equal to under root of 16 plus 16 is equal to under root of 32. PQ is equal to RS from the equation 1 and 3 and QR is equal to PS from the equation 2 and 4. A quadrilateral is a parallelogram if both the pairs of its opposite side are congruent. Therefore rectangle PQRS is a parallelogram. Therefore point PQR and S are the vertices of the parallelogram. Question 6. Show that the point A, B, C, D are the vertices of the rhombus ABCD. Distance between the 2 points calculated by the distance formula under root of x2 minus x1 square plus y2 minus y1 square. First of all, calculate the distance between A and B, then B and C, then C and D, and then A and D. We get distance between the AB is equal to under root of 90, while distance between the BC is equal to under root of 90. Distance between the CD is equal to under root of 90 and distance between the AD is equal to under root of 90. So AB is equal to BC is equal to CD is equal to AD. In a quadrilateral, if all the sides are equal, then it is a rhombus. So square ABCD is a rhombus, or rectangle ABCD is a rhombus, and the point A, B, C and D are the vertices of rhombus ABCD. Question 7. Find the x if the distance between the point L, x and 7 and the m 1 and 15 is 10. आता इथे फॉर्म्युल्यामध्ये बदल हा झालेला आहे की इथे L चा कोऑर्डिनेट x दिलेला आहे आणि त्यांच्या मधातलं डिस्टन्स दिलेला आहे 10. मग इथे काय करावं लागेल आपल्याला x1 y1 x2 y2 आणि डिस्टन्स किती दिलेला बाय डिस्टन्स फॉर्म्युला डिस्टन्स दिलेला आहे 10. मग इथे x1 आणि y1 च्या किंमत ठेवून x2 आणि x1 y2 आणि y1 च्या किंमत ठेवायच्या आणि डिस्टन्स आपल्याला दिलेला आहे. म्हणजे आपण काय करणार 10 इज इक्वल टू अंडर रूट ऑफ 1 मायनस एक्स स्क्वेअर प्लस 8 स्क्वेअर स्क्वेअरिंग बोथ साइड वी गेट 100 इज इक्वल टू 1 मायनस एक्स स्क्वेअर प्लस 8 स्क्वेअर. Therefore 1 minus x square is equal to 100 minus 64. 1 minus x square is equal to 36. Taking square root of both sides we get 1 minus x is equal to under root of 36. Therefore 1 minus x is equal to plus minus 6. 1 minus x is equal to 6 or 1 minus x is equal to minus 6. X is equal to minus 5 or x is equal to plus 7. The value of the x is minus 5 or 7. Question 8. Show that the point A, B, C are the vertices of an equilateral triangle. Distance between the 2 points is equal to under root of x2 minus x1 square plus y2 minus y1 square. Distance between the AB is equal to under root of 1 minus 1 square plus 6 minus 2 bracket square. Therefore under root of 0 square plus 4 square is equal to under root of 4 square. Therefore distance between the AB is equal to 4. Distance between the BC is equal to under root of 1 plus 2 upon 3 minus 1 square plus 4 minus 6 square under root of 2 under root 3 square plus minus 2 square is equal to under root of 12 plus 4 is equal to distance between the BC is equal to under root of 16 is equal to 4. Distance between the AC is equal to under root of 1 plus 2 upon 3 minus 1 square plus 4 minus 2 square under root of 2 under root 3 bracket square plus 2 square. Therefore distance between the AC is equal to under root of 12 plus 4 is equal to under root of 16. So distance between the AC is equal to 4. AB is equal to BC is equal to AC. Therefore triangle ABC is an equilateral triangle and the point ABC are the vertices of equilateral triangle. Vertices of equilateral triangle. In this way we complete the practice set 5.1. Thank you.